Hi everyone. In this brief landscape tour, what I'm going to do is show you the main features of glacial erosion. And there's no better place to start doing that than to look at a corrie. It's really important that you're able to get the shape of a corrie fixed in your head in order to be able to explain it for marks in the exam. As you can see in this example, a corrie is a deep, scooped out basin shape. And it's got these steep back side walls, back and side walls. There's loads of evidence of freeze thaw shattering the top edges of these walls, steepening them. You can see where the glacier that formed in this hollow on this hillside has scooped out and deepened this shape through the processes of rotational flow. The glacier would have filled this hollow and flowed downhill from this corrie hollow. Once the glacier is melted, a tarn or a corrie lochen forms down here, and not quite so visible in this image I'm using is the rock lip at the front. But the basic idea is to get in your head this scooped out corrie shape. Now, I've mentioned here talking about how the glacier that forms in these corries flowed out of the corrie and then travelled following gravity downhill, following the path of least resistance through the landscape. If we just travel around the corner, there's a great example that will help you understand that process. Here we are in the same area of the landscape, and we can see another scooped out shape in the landscape here. Now, you can imagine the corrie, the glacier that formed in this corrie, flowing downhill. The snow built up into layers of neve ice. As it did so, the bottom of the ice would have become lubricated as basal lubrication took place, and the ice flowed out down through the landscape, and it followed the path of least resistance as it did so. Now, what that means is the ice followed the easiest path. It has no reason to choose a more difficult path. So it follows the route down through the landscape where the rock is easily eroded. Perhaps a route was already carved for it by a pre-existing river that flowed through this landscape prior to the glaciation. And you can see that as this glacier flowed out of its corrie, down the valley, it then started to erode this U-shaped trough that we see. And that has the steep sides and the flat bottom characteristic of a U-shaped valley. And that little image there lets us really explore this concept of the corrie being where the glacier is born, where the snow builds up, turns to neve ice, builds up to a thickness where basal lubrication causes the bottom of the ice to melt, then gravity can push that stream of ice downhill. The ice follows the easiest path through the landscape, and as it does so, it erodes through abrasion and plucking a glacial valley with steep sides and a flat bottom to make a U-shaped valley. Where there would have originally been hills making up this valley landscape, those hills have been cut in half by the passage of the glacier, leaving these steep-sided truncated spurs on each side. And where there were tributary valleys that would join on to that river valley that existed in the past, those have been left as hanging valleys on either side. You can see this hanging valley here, left hanging high up above the edge of the valley sides. Now that's the kind of process in miniature, but if I take another little hop and a skip and a jump in the landscape here, just over to this section of the landscape, here you can see I've laid out a network of corries because it's often the case that corries are not found on their own. And this gives you an even greater appreciation of the processes at work here. Here we have one corrie, and next to it a second corrie, and a third corrie, and a fourth corrie. And they all would have been building up in layer on layer of snowfall, compression turning that snow to neve ice, the pressure of the ice melting the glacier's bottom through the process of basal lubrication, and all of these corrie glaciers would have started flowing downhill assisted by gravity, following the path of least resistance down through the landscape. Of interest to you here is that where our corries 3 and 4 have developed next to each other, you can see that between them there is a kind of ridge-like feature. And that is a good example of an arete. The photos I show you in class are often of very exaggerated sharp rocky outcrops, and that's useful for learning from a photo. But in reality, this is often what an arete looks like. It is a sharp ridge between two corries. If we were just to look down the back side of this mountain here, you can see that though it's less well defined, I'm not sure that I would classify this scooped out hollow here as a full corrie. If you were able to accept that that was a corrie, or imagine that it was, then in between the three here we would have the beginnings of a pyramid peak, as the three corrie walls would erode back towards each other. Now, as we use this as our starting point, you can see that corries 1, 2, 3 and 4 all started here, and the glaciers that formed in those corries flowed downhill, following the path of least resistance through the rocky landscape, eroding it as they went through the processes of plucking and abrasion. And then they, presumably because it was easier for the ice to flow in this direction, perhaps because the rock type allowed it to erode it this way, perhaps because there was a pre-existing river valley that the ice was using as its path of easiest movement, it then eroded this spectacular U-shaped valley. And on either side of this U-shaped valley you can see the truncated spurs of where the ancient hillsides that made the pre-glacial landscape have literally been chopped in two, and these steep, cliff-like, sliced-off sections of the hillsides can be seen. You can literally see in cross-section the shape of the ancient hill that existed before the glaciers, and the slice that's been made across it by the ice as it has eroded it away. You can see the misfit stream in the base of the valley here, so called because this river could not possibly have eroded a valley of this size. And you can also see, though better examples do exist, examples of hanging valleys flowing down from the side, where tributary streams to that ancient river valley have been left stranded high up as the glacier has eroded this deep trough. So, in summary, you can see that we've travelled down a U-shaped valley with its flat bottom and steep sides. You can see that as we fly back up the valley here, you can kind of get an idea of the scale of the scenery that we're trying to learn about. You can see that the corries where the glaciers began actually are often found in kind of clusters or networks next to each other, that where two corries are found or border each other, an arete can form as they erode towards each other, and even sometimes we can find pyramid peaks where three corries erode back to back. And you can see that triple join point there. So it is of course one of the world's, and certainly Scotland's, most spectacular landscapes, and very worth understanding. So I hope that helped get you an image in your head of the kind of feature that we're trying to learn.